Hello and welcome to this tutorial on data normalization with Python. In this tutorial, we will learn about the basic of data normalization and how to apply it using Python. Normalization is a process of transforming data into standard format, which helps to remove any redundant and inconsistent information and improve the accuracy of data analysis. We will discuss the importance of data normalization and how it can be useful in various data analysis projects. By the end of this tutorial, you will have a clear understanding of the normalization process and be able to apply it to your own data. So let's get started. Data normalization is a common data preparation technique in machine learning, which is used to transform features to similar scales in order to improve the performance and the training stability of the machine learning model. When features have different scales, it can cause problems during model training, such as slow convergence, difficulty in comparing the magnitude of different features, like here, age. So the values is like 63, 37, 41. But if we look, for example, CP, it's 3, 2, 1. So there is a it's difficult to compare the values of age comparing with the other like the CP feature. Okay, so data normalization addresses these issues by bringing all features to a similar scale, typically between 0 and 1 or -1 and 1. Normalization is an important data preparation technique in machine learning because certain algorithms are sensitive to scaling. For example, distance-based algorithms like k-NaN, k-means, and support vector machine use distance between data points to determine their similarity. Actually, these algorithms are most affected by a range of features, as larger features can dominate smaller ones in terms of distance. Machine learning algorithms also like linear regression and logistic regression use gradient descent for optimization, which requires data to be scaled. Having similar scale features can help the gradient descent coverage more quickly toward the minimum, improving the training speed and accuracy of the model. So, on the other hand, tree-based algorithms like decision tree and random forest are not sensitive to the scale of the features. This is because decision tree only split node based on a single feature, and this split is not influenced by other features. Normalization techniques are widely used in machine learning to pre-process data and improve the performance and stability of machine learning models. Among the different normalization techniques available, two of the most common used techniques are minimax scaling and z-score normalization. Minimax scaling is a normalization technique that scales the features to a range between 0 and 1. This technique works by subtracting the minimum value of each feature from the original value and divide it by the difference between the maximum and minimum values of the feature. Minimum-maximum scaling can help to improve the stability of machine learning models by reducing the impacts of outliers and bringing features to a similar scale. Let's consider an example of minimax normalization to illustrate how this technique works. We have 5 numeric values: 14, 9, 24, 39, and 60. The minimum value is 9, okay, and the maximum is 60. To apply the minimax normalization, we subtract minimum value from each value and divide it by range between the minimum and maximum value. This scales the value to a range between 0 and 1. So, for the value 9, the normalization value would be 9 minus 9 over 60 minus 9, which will be 0 over 51, which is equal 0. For the value 14, the normalized value would be 14 minus 9 over 60 minus 9, which equal 5 over 51, which equal 0.098. So, and so on, that for the 24 will be 0.29. For the 39 will be 0.58. For 60 will be 1. So as you can see, minimax normalization scales the value between 0 and 1 based on the minimum and maximum value of the data. This technique can help to improve the performance and the stability of machine learning models by bringing features to a similar scale. Now, let's take a look at how to perform minimax normalization in Python using sklearn library. Here is an example code snippet. First, we import the minimax scalar class from the sklearn preprocessing model. Then we create an instance of the minimax scalar class called scalar. Next, we fit the scalar object to our data using the fit model method. This calculates the minimum and maximum value for each feature in the data, which will be used to scale the data later. Finally, we transform the original data using the transform method of the scalar object. We create a new data frame called norm data with the transformed value and the original column names. Actually, this example demonstrates how easy it is to perform minimax normalization in Python using sklearn. Minimax scaling is normalization technique that scales values to a fixed range, usually between 0 and 1. It can be useful in situations where the data doesn't follow Gaussian or normal distribution. In machine learning, it's favored for normalization algorithms that don't follow any distribution, such as KNN and neural networks. This is because these algorithms are based on distance or similarity measure and rely on having features that are on a similar scale. It's important to note that normalization is affected by outliers. If the dataset contains extreme values, they can affect the scaling of the other values, resulting in compressed or expanded range. Therefore, it's important to handle outliers before applying normalization techniques. Also, it is recommended to compare the results of different normalization techniques and choose the one that produces the best performance for a specific problem at hand. Z-score normalization, also known as standardization, is a technique that scales features to have mean of 0 and standard deviation of 1. This scaling follows the standard normal distribution property. The formula to compute the z-score of a feature is x minus mu over sigma, where x is the original value, mu is the mean or average of the feature, and sigma is the standard deviation from the mean. This formula ensures that the rescale features have a mean of 0 and a standard deviation of 1. Z-score normalization is useful when the data follows a normal or Gaussian distribution, as it allows us to compute the relative position of values across different features. It's also a good choice when dealing with a linear models such as linear regression that assumes that the features are normally distributed. However, Z-score normalization can be affected by outliers, as extreme values can affect the mean and the standard deviation. Therefore, it's important to handle outliers before applying this normalization technique. Additionally, like with minimax scaling, it's recommended to compare the results of different normalization techniques and choose the one that produces the best performance for the specific problem at hand. This example shows how to calculate the z-score normalization value for a set of 5 numeric values: 14, 9, 24, 39, and 60. So first we calculate the mean of the data, which is 14 plus 9 plus 24 plus 39 plus 60 over 5, which is equal 29. Okay, and then we calculate the standard deviation, which is the square root value of every value, this one 14, sorry, minus the mean, okay, all square, okay, and the second value minus the mean and all square, and so on, all of them divided by 5. So the standard deviation is 18.49. Next, we use the z-score normalization formula to transform each value into its standard form. For example, for the value 14, the formula is 14 minus 29 over 18.49, which will be equal minus 0.811. Which means that the standardized value of 14 is minus 0.811. Similarly, we have computed the z-score normalized values for the other 4 values, 9, 24, 39, and 60. The resulting z-score normalized values have a mean of 0 and a standard deviation of 1, which is the desired property of a standard normal distribution. In this example, we need to calculate the z-score using Python. The code starts by importing the standard scalar class from the sklearn.preprocessing module. Next, it creates an instance of the standard scalar and assigns it to the scalar variable. Then, it fits the scalar to the data by scaling the fit method on the scalar object and passing in the data as an argument. After the scalar is fitted to the data, it can be used to transform the data into normalized form. To do this, the code calls the transform method on the scalar object and passes in the data as an argument. This returns an array of normalized values. Finally, the code creates a new data frame called nor_data and assigns it to the normalized values. The column parameters is used to specify the column names for the new data frame, which are taken from the original data. Overall, this code demonstrates how to use standard scalar class from the sklearn.preprocessing module to normalize data using z-score normalization. And that concludes our tutorial on data normalization with Python. We hope you found it informative and useful. Remember, normalization is an essential step in preparing your data for machine learning models, and it can help improve their performance and stability. We covered the 2 most widely used normalization techniques, minimax scaling and z-score normalization. Minimax scaling is recommended when data doesn't follow Gaussian or normal distribution, while z-score normalization is suitable for normally distributed data. Lastly, keep in mind that normalization is affected by outlier, so it's crucial to handle them appropriately before normalize your data. Thank you for watching and happy coding. coding.